Shutter speeds! Oh boy! Now we get to part 3 of 4, or maybe 5, whatever, 5 I believe, of camera settings. This time around we get to shutter speeds. You see those numbers above? Those numbers are going to be your shutter lengths. Starting at 10 seconds, which is the minimum you're going to want to use to record the Milky Way, and then going up to bulb mode, which is any exposure lengths above 30 seconds. Anything below 10 seconds is not long enough to allow the necessary amount of light into the sensor. Anything significantly over 30 seconds, even with the widest focal lengths, will lead to star trails. Now compare both images above. The one on the left is an example of a shutter length too short, and the one on the right is an example of a shutter length that's way too long. Now take a look at this image. I shot this with my 5D Mark II and my Rokinon 14mm f2.8. Exposure length of only 6 seconds. It was 6 seconds. And even at 5000 ISO, it just was not enough to capture enough information. Even attempting to brighten it up, it would have produced far too much noise to be a usable image. Now this image was taken with the same camera and lens combination, but the exposure length was over 1 minute long. As you can tell, there's some serious star trailing in this. I actually purposely took this image at over 1 minute for a specific reason, and we will get into that in the next course, or a later course I should say. There's an easy formula to determine the maximum exposure that you can take before you get star trailing with your own camera and lens combination. You will be taking the focal length that you'll be shooting with and dividing it by 500. Now of course, to shoot the Milky Way, you're going to be using the widest focal length that your lens is capable. So, for my Rokinon, which is a 14mm, I will take 500 divided by 14, which will bring me 35.71 seconds, and we'll just round down to 35 seconds. Now, if you had a 20mm lens, 500 divided by 20mm, that would make for 25 seconds. Now here's a kicker. If you're shooting with a crop sensor camera, well, you gotta take the focal length of the lens and multiply it by the camera's crop factor. So Canon cameras are 1.6 crop and Nikons are 1.5 crop. So if you're shooting with a Canon, you would take that 20mm lens and multiply it by 1.6. Of course, then that makes it equivalent to a 32mm lens. So then back to the formula in photographing the Milky Way. We take that 32mm lens equivalent. 500 divided by 32. What does that make it? Let's find out. So, with all that formula mathy stuff, if I put my 14mm lens on a crop sensor camera, I would be able to get away with only a 20-second exposure. Anything longer than that, it would be star trailing. And that's one of the reasons why crop sensor cameras would have a slight disadvantage in astrophotography. But if all you have to work with is a kit lens and like a consumer grade camera like a Canon Rebel or something, don't think that you can't actually get away with doing this and taking good shots of the Milky Way. The photo above you was one that I took actually many years ago with a crop sensor camera and a Canon kit lens. I actually shot this with the Canon 50D, which is a very old camera, with the Canon 18-55 kit lens. Now this photo, it was actually taken quite recently, but I shot this with the Canon Rebel T2i, which is somewhat of an older consumer grade camera. I also shot it with my 24mm lens and on a 1.6 crop camera, 24 times 1.6. Yeah, it was a pretty short exposure. And to top it off, the moon was out. That just goes to show you, with the techniques that I will be teaching you, regardless of the camera equipment you're working with, you could actually get some pretty dang good shots of the Milky Way.